Hey, this is Mr. Mitchell. We have a video about heating curves and thermal expansion. But before we get to that, I want to talk about, remind you about what we talked about objects and the particles, the molecular particles in objects. And this comes from what is called the kinetic theory. So if you hear the term kinetic theory, that's where it comes from. You may remember kinetic from kinetic energy. Kinetic energy is actual motion. And once you see the kinetic, or reminded of the kinetic theory, then you'll see why they call it that. According to the kinetic theory, all matter is composed of tiny particles, and these particles are constantly moving. So even if you have a solid that appears to be still, the kinetic theory says there is movement, molecular movement at the molecule level of these solids. So you may remember also that the way you get from a solid to a liquid to a gas is to add heat. So a solid, if you add enough heat, it will make it a liquid. If you add enough heat more, then it will become a gas. Now, the terms I want to introduce you to down here are ones you probably have heard of. The melting point and the boiling point. That point where a solid becomes a liquid is traditionally called its melting point. And the place where a solid that's right in between stages between liquid and a gas is typically called a boiling point. Now you may hear of other terms like point of fusion is sometimes heard for melting point, and point of vaporization for boiling point, and that's fine, but these are kind of the traditional terms, melting point and boiling point, for in between these stages. Now, once you add energy, and once you add heat to a solid, it will gradually get more toward the liquid stage. However, to actually cross over from solid to liquid, to actually have these bonds break, you have to add more energy right at that point of the melting point. Same thing with liquid and gas. You have to add more energy or heat right at that boiling point, and that can be seen on this heating curve that is right here. This is a heating curve for water. And what you have at the bottom the amount of heat added, and that's going to be constant. And then you have the temperature. So what's going to happen is on this heating curve, you can see a constant amount of heat is being added. This is just like constant speed on a distance time graph. This diagonal line means a constant amount of heat is being added. However, that heat is still added even though we have a straight line. The straight line means it takes extra heat, takes extra energy for the ice to finally become water. Even though the heat added is going to be constant, these straight flat lines represent the extra heat that is added to get it to that point. You can see it's the melting point here. And the same thing between a water and a gas, you have that straight flat line there, which represents that it takes extra energy or extra heat to get it from water to a gas. And that's going to be true for everything that is a solid, whether it is water or whether it is something else. Well, water is solid in the form of ice. So these are called heating curves, and I want you to know why we have the flat lines here. And I also want you to know what the kinetic theory says about matter and how it's constantly moving, and kind of the whole adding more heat is how you go from solid to liquid to gas. Let's now talk about thermal expansion. Thermal expansion. As energy is added to an object, as heat is added to an object, it expands. Now, many times we can't see it expanding, but for those of you who wear rings, you know that sometimes the rings are easily put on and sometimes the rings are hard to get on. Now, I know there's also the size of your finger has something to do with your diet, but whenever it is hot, the ring is bigger than whenever it is cold. And the same thing is true for something like concrete. I don't know if you can tell, but these concrete pictures, this concrete picture has lines across it. And when people pour concrete, they anticipate that concrete expanding. Because if it expands and you do not have these pre-made cracks in the line, the cracks are going to happen, like right down here. So the concrete was poured, it got hot, and it expands. And if you're lucky, the expansion will be taking place in this groove that's already there, as opposed to just happening wherever. You can see this over here. This is something you often see at bridges. You have this space here between road segments. This space is for thermal expansion. When the road is hotter in the summertime, the road will expand and it will push this way and it'll push this way, and you'll have that little bit of space right there so the road does not buckle. This is also seen in thermometers. Now, I don't know if you realize this, but a thermometer has very little liquid in it. Now, at some point that liquid was mercury, but I think most thermometers now you have dyed alcohol, red dyed alcohol. But what happens is this liquid in the thermometer is in a very small space. So what happens to liquids whenever they are heated up? They expand. And you can see from this diagram you have all the molecules together, but when you have more heat, the molecules have no place to go but up as they expand. And I think it's very clever how thermometers were made, because if you can tell how much it will expand in 10 degrees, for example, then that would be the space that you put for 10 degrees on a thermometer. I think that's very clever, and it's a good example of thermal expansion. This also happens with hot air balloons. You may have noticed on hot air balloons you add heat. When heat is added, the density of the air becomes lighter because you have that expansion. Just like the density here is less than it is here. There's much more dense over here. So before the fire is lit and before the hot air is added to the balloons, it is more dense, but it is less dense whenever you add to it. And what that does is all the air around it suddenly becomes more dense than the air inside, so that makes it rise. Well, I hope you've learned a little bit about thermal expansion and a little bit about heating curves.